So, here we are going through 3 more AS level maths questions on stationary points with differentiation. These are much harder and worth a lot more marks than the first set. Let's do this. Alright then, first up, a curve C has equation f of x is x minus 2 times x minus 3 whole squared. Determine the exact coordinates of the turning points of C, so the stationary points, and we also want to determine the nature of each turning point. Okay, 8 marks. So the first thing we are going to need to do is expand the brackets. So, part A. F of x then, we can write as x minus 2 times x squared minus 6x add 9. Now, make sure that you can then expand that to get x cubed minus 8x squared plus 21x minus 18. Okay, so now the function is in a usable form. A good next step to take would be to say that at turning points the gradient is equal to 0. So we should write down at turning points df by dx is equal to 0. And you would get a mark for writing that down. So next we need to find df by dx. So that is gonna be 3x squared minus 16x plus 21. Okay, so now we're gonna set that equal to 0. Now I'm gonna factorize it too. So to get the 3x squared, we're going to need a 3x and an x. Now the number at the end is positive, but the number in the middle is negative. Both signs then are going to be negative. So numbers that multiply together to give us 21 only really gives us 3 and 7. So if we put a minus 3 in there, that multiplies 3x to give us minus 9x, and then a negative 7 in there takes us down to minus 16x. So now then, our two x values are 7 over 3 and 3. So we also now need to find the y coordinates. So to do that, we're going to use the original form of the equation. So x minus 2 times x minus 3 squared. So when x is 7/3, y is 7/3 minus 2 times 7/3 minus 3 squared. Now, 7/3 minus 2 is just 1/3. 7/3 minus 3 is 7/3 minus 9/3, so that's minus 2/3. Squared, so that's 1/3 times 4/9, so that's 4/27. So, one of our stationary points is at 7/3, 4/27. Now the other one is much easier. So when x is 3, y is 3 minus 2 times 3 minus 3 squared. So our second bracket is 0, so y is 0. So the second stationary point is at 3, 0. So now we need to determine their nature. Now to do that, we need to find the second derivative. So, d squared f by dx squared is going to be 6x minus 16. Now when x is 7/3, the second derivative is going to be 42/3 minus 48/3, which gives us minus 6/3 or minus 2. So that's negative, which means 7/3 4/27 is a maximum. Now when x is 3, we are going to get it's going to be 6 times 3, which is 18, minus 16, which gives us 2. Now that's greater than 0, so 3, 0 is a minimum. Okay, then part B wants us to state the coordinates of the turning points of y equals f of x plus 1 minus 4. So f of x plus 1 is a translation 1 to the left, so we need to subtract 1 from the x coordinates, and then the minus 4 moves us 4 down, so we're subtracting 4 from the y coordinates. So the maximum is now going to be at 4/3, and then minus 104/27, and the minimum is now going to be at 2 minus 4. Okay, number 2. Prove that the curve with equation y equals 2x to the 5 add 5x to the 4 add 10x cubed add 8 has only one stationary point stating its nature, 6 max. So again, a good way to start at stationary points dy by dx is equal to 0 and find dy by dx. So we are going to get 10x to the power 4 add 20x cubed add 30x squared. Okay, so we are now going to set that equal to 0. Alright, so first of all we have a common factor of 10 running through, so let's get rid of that. So we're going to end up with x to the 4 add 2x cubed add 3x squared is equal to 0. Okay, now we also have a common factor of x squared running through. However, we don't divide algebra away because then we lose solutions. So instead, we now factorize. So we're taking out a factor of x squared, which is then going to leave us with x squared add 2x add 3 inside the bracket now this then tells us there is a stationary point when x is equal to 0. Now to prove there are no more stationary points, we now need to think about the roots of the quadratic. So, 4 x squared add 2x add 3 equals 0. We're going to think about the discriminant. So b squared minus 4ac is going to be 4 minus 4 times 1 times 3, so minus 12. Now that gives us minus 8. Now when b squared minus 4ac is less than 0, that means there are no real roots. So that tells us now the stationary point at x equals 0 is the only one. So now we need to find the y-coordinate. So when x is 0, y is just gonna be the number at the end, so minus 8. So the stationary point is at 0, minus 8. Now, okay, final question, 11 marks altogether, so good times. This time y is 2x squared minus 8x root x, add 8x, add 1, 4x greater than or equal to 0. We want to prove that the curve has a maximum point at 1, 3. 9 marks. Okay, so to get all 9 marks, we need to check everything, including that the point even lies on the curve. So let's check that first of all. So when x is 1, we're going to get y is 2 minus 8, add 8, add 1, which does indeed give us 3. So that tells us 1, 3 is on the curve. Okay, next we need to check that it is a stationary point. So, again, we could say that for a stationary point, dy by dx must equal 0. So we're going to find dy by dx, sub in x equals 1, and hopefully we will get 0. So the first thing we need to do is rewrite y. So y is 2x squared. Now we have minus 8x root x. So that's minus 8x to the 3 halves. Add 8x, add 1. Now let's differentiate. So dy by dx is going to be 4x minus, now 8 times 3 halves is 8 times 3 divided by 2. So that's 24 divided by 2, so that's 12. So we have minus 12 x to the power 1 half, add 8. Now, if you like, we can think of that as 4x minus 12 root x add 8. Now, when x is equal to 1, dy by dx is 4 minus 12 add 8, which does indeed give us 0. So that tells us 1, 3 is a stationary point. So now we just need to prove it's a maximum. So for a maximum, d squared y by dx squared has to be less than 0. So d squared y by dx squared is gonna be 4 minus another half multiplies 12, so we get 6x to the minus 1/2. Which we can write as 4 minus 6 over root x. So when x is 1, the second derivative is going to be 4 minus 6, which is minus 2. So we've checked everything. Now we should finish by saying, therefore, 1, 3 is a maximum. Okay, then part B for 2 marks wants us to find the coordinates of the other stationary point and classify its nature. So, for stationary points, dy by dx must equal 0. So we are going to set 4x minus 12 root x plus 8 equal to 0. Now we have a common factor of 4, so let's divide that away. So we get x minus 3 root x add 8. No, we don't, sorry, add 2 is equal to 0. Now, from here, there are a few methods we can use. So, I'm going to use substitution to turn this into a quadratic because it's good practice. So, if we let some letter m be root x, then m squared is x. So the quadratic is then m squared minus 3m add 2 is equal to 0. Now this factorizes to m minus 1 times m minus 2. So that gives us either m is 1 or 2. Now remember, we said that m was root x. So root x is 1, gives us the one that we know. X is 1. The one that we don't know is when root x is 2. Square that and x is 4. So the x coordinate of the second stationary point is 4. So, now that we know the x coordinate, we need to find the y coordinate. So, when x is 4, y is 2 lots of 4 squared minus 8 times 4 times root 4 add 8 times 4 plus 1. So that is going to give us 32 minus 64 add 32 add 1, which just gives us 1. So So the coordinates are 4, 1. Now we just need to classify its nature. So x equals 4 gives us second derivative of 4 minus 6 over root 4, so 6 over 2 is 3, so we have 4 minus 3, which gives us 1, which is greater than 0, so this guy is a minimum. Okay then guys, that's thankfully those questions done. They were pretty tough. The next one in the playlist is going to be normals and tangents. Hope to see you there. Take it easy. Take care.